Alright, let's go to the third topic, which is total internal reflection. So before we go into total internal reflection, let me explain first what critical angle is. Critical angle usually happen when the light passes through a denser medium to a less dense medium. So this would cause the refracted ray to be at 90 degrees from the normal. But it isn't always the case. It depends on the types of material and also the incident angle. The incident angle is called critical angle. So basically I'm going to simplify this. A critical angle is the incident angle which causes the refracted angle to be 90 degree. Or you can calculate them using sin theta c is equals to n2 over n1. So why do we need to know about critical angle? Because it's related to total internal reflection. So for example, let's say my incident critical angle is 30 degree. So this causes my refracted angle to be 90 degree. But if I increase the value to more than 30 degree, meaning the angle of incident is larger than the critical angle, let's say 50 degree, what will happen is no transmission will occur. So it will be reflected back into the medium at the same angle. So that's why it's called total internal reflection. It totally goes back into the medium at the same angle of the incident. So this is TIR. Another example of total internal reflection is a prism. I'm not sure whether you've done this before, but in school, the teacher used to ask us to, build a telescope and so on. So what we use for that is a prism. So how does a prism work? Okay, let's say at any angle you shine the light through, what will happen is TIR will make the refracted angle be reflected back at the same angle of incident. So let's say this is my incident angle. Okay, so the same angle will be for the refracted. Another example here, at a different position. So light goes in at a certain angle, and then TIR happen, it goes back into the medium, also at the same angle. So what are the applications of TIR? There are plenty. For example, a telescope, a binocular, and so on. So what you can do is go and find another example of total internal reflection from the internet. We can go through YouTube's and then try to understand how it works. Other examples such as sparkling of the diamond as well as optical fiber and so on. Let's do an example. A light ray passes through a glass, then incident on glass air boundary. Determine the critical angle for glass given n air is equals to 1 and n glass equals to 1.5. Take out all the values. Okay, first, the clue here is passes through a glass, incident on air. So we have a glass here, we have air here. So glass air boundary. And then light passes through. Let's say this is the normal line. Determine the critical angle, meaning the refracted ray is 90 degree. Okay. Or you can draw it through a different way. Let's say this is glass and this is air. So again, light goes in. This is the normal line. It will be refracted back at 90 degree. So what are the values? We have n air, which is the second medium. We have n glass, which is the first medium. So this is your n1. This is your n2. So to calculate critical angle, we have to use sin theta c is equals to n2 over n1. So your theta c will be sin negative 1 n2 over n1, where your n2 will be your index of refraction of air, and your n1 is the index refraction of glass. So put that in here, 1 over 1.5, and you will get 41.8 degrees. Okay, let's go to the next one. Can you do these questions? Try to do number 2 and 3 and check your answers. Again, if you can't solve it or if you have any question, just come to me. Okay, another recap. Critical angle is defined as sine theta su is equals to n2 over n1, or incident angle, which causes the refracted angle to be 90 degrees. Again, let's go to the next one, which is dispersion. What is dispersion? Now, we all know most of the light used, the color would be white. If you notice, most people would use white color. So, how does these lights have different colors? All these lights have different wavelength, which makes, and the combination of all the light colors makes one color, which is white light. So actually, white light, you can disperse them into 7 colors, which are the rainbow colors, are red, orange, yellow, green, blue, and violet. So how do we disperse the white color? Easy. What we do is we can use a prism. An example is we can use a prism. So if you put a prism and then shine a white light through it, this white light will break into the 7 colors, and all 7 colors have different wavelength depending on the type of color. For example, violet has the smallest wavelength of 400 nanometer, and red color has the highest wavelength of 700 nanometers. You can see here violet is at the bottom, whereas red color is at the top. So those are the difference in wavelength. So the spreading of white light into the full spectrum is called dispersion. I'll give you another example, which is rainbow. Let's say it is raining. These here are rains during daylight, meaning white light are circulating around the surrounding from the sun. So the sun gives you a white light, and then it shines through the droplets of water. So these droplets of water will start to disperse the white light into 7 colors. So that's how rainbows are created. So what you can do is, again, just go through and find an example of dispersion, and then total internal reflection, and if you have the time, go and look through thin lenses, because this will be the next topic that we are going to learn next week.